So after discussing the failure criteria for the ductile material, now we are going to uh, discuss the failure criteria for the brittle material under the plane stress conditions. So we have discussed earlier that ductile material, they usually follow the shear stress plane, and the brittle material, they follow the normal stress plane. So recalling these that fundamental concepts, we will discuss that how we will consider the material which is brittle, that is safe or not. So, so in the ductile material, the failure is characterized by the yield strength, but in the brittle material, there is no yielding, so the material ruptures suddenly. The fracture is different from the ductile material in which necking occurs, but in the brittle material there is no such type of necking, and it occurs immediately. So brittle material fail uh, suddenly through rupture or fracture in a tensile test. So what is the criteria? Uh, Maximum normal stress criteria, also called is the Coulomb's criteria. What it tells us that the structural component is safe as long as the maximum normal stress is less than the ultimate tensile strength of a tensile test specimen. So again, we are compare the actual stress state with the properties of the tensile test for any material. So we are comparing here the ultimate strength of the material under any loading condition with the tensile test specimen. Any loading means that is under the plane stress condition, in fact, uh, but we are comparing it with the tensile test specimen. So, so simply, we have the ultimate tensile strength. This is the principal stress, one principal stress, this is the other principal stress. So if it is less than the ultimate tensile strength of the material, so the point will lie inside these squares, and we will consider that as the safe state of the stress. So uh, so we can note that the ultimate tensile strength in the tension and in the compression, it is same. So which is the disadvantages of this criteria, that for different materials, the ultimate tensile strength in tension and compression is not the same. So this criteria suffer from an important shortcoming. It is based on the assumption that the ultimate strength of the material is the same in tension and compression. This is the disadvantage of that criteria, that it yields better results for the tension, but for the compression, the results are not realistic. So according to this criteria, if uh, we have we find out the principal stresses from the Mohr circle, and these principal stresses lies inside these squares. If the principal stresses are both positive, both negative, if it lies inside this, then you will say the material is safe. So sigma A, that must be less than sigma U, sigma B must be less than sigma U. So also known as the Coulomb's criteria, after the French physicist Charles Augustin de Coulomb. So many contributions from the Coulombs in the mechanics side and different areas of the engineering. Uh, so there is another criteria given by the German engineer Otto Mohr, and this is just to overcome that disadvantage that the ultimate tensile strength for the any material in the compression that is different from the tensile ultimate tensile strength. So it needs separate tests for any material under tension and in compression as well. So we cannot say that the properties in the tension and properties in compression that are same. So we have to verify through experiments and get different data for the tension and compression for any material. So sigma ut and sigma uc is the ultimate strength in tension and compression, uh, which corresponds to the rupture of the tensile test specimen and compressive test specimen. If both stresses are positive, the state of the stress is safe as long as sigma A that is less than sigma ut, sigma B that should be less than sigma ut. If both are negative, then it must be less than the tensile strength in compression. So graphically, we can say that if it is in the pure tension, this is the pure compression. So this is the Mohr circle for the tension, which is usually small. In compression, the strength is more as compared to the tensile test. So cracks are generated, they are fastly growing, quickly rupturing when we are going to open that. Unlike the case in which when we compress, so most of the cases it heals, it closes the cracks of the material, defects of the material. So that is why in compression, most of the material they have higher strength as compared to the tension. So there are two ways to represent these criteria graphically. One is the Mohr circle, and the other one is the simple in which we can plot the sigma A and sigma B on the x and the y axis. So simply marking the ultimate tensile strength for tension and compression. So we will get these two squares for the cases in which we have pure tension and pure compression. So this is for the Mohr circle for the pure tension, and this is the Mohr circle for the pure compression. So any circle residing inside the circle for any state of the stress will be considered as safe. So the red circles, they are inside these black big circles, so they are considered as the safe. Similarly, any point which resides inside these squares, that will be considered as the safe state of the stress. So what when sigma A and sigma B have opposite sign, just like in the torsion cases? In the torsion test, we have the one principal stress is positive and the other is in the negative. And we will compare the ultimate strength in the shear. So graphically, when we draw the Mohr circle for the shear stress for the torsion cases, we this is the origin of the circle, and this is the shear stress in one direction, shear stress in other direction. In this case, we plot the circle. So connecting this point of the circle and through this point, so this makes some area and any state of the stress which resides, any circle which is drawn inside this area that will be considered as the safe state of the stress. So on another graph it will be shown like this, that is for the positive and negative, where one stress is positive and the other one is negative. So it will be like this. But it is difficult to draw this curved line graphically, how to draw this curve. So there are some simple methods by which we can just assume that, okay, just draw the straight lines and consider as the failure criteria. So understanding this condition, that how it evolved, how it evolved, that this is the pure torsion cases, pure tension cases, and pure compression cases. And combining all these give us some area. So any circle residing in this area, that will be considered as safe state of the stress. And any circle which is outside this, and that will be not, that will be considered as the fail criteria. So simplifying this criteria, we can plot this as the straight lines between these 2 points for the torsion cases. So if in the torsion cases one principal stress is negative, the other one is positive, it lies inside this triangle. So we will say that the material is safe. If it lies outside, then vice versa. So how it came? It came that if we draw tangents of A and B and connecting these two circles, so there will be another circle for any state of the stress having different principal stresses, positive and negative, just like the torsion cases, not the pure torsion, but closely to the pure torsion cases. So any circle which lies inside this region, that will be considered as safe. So there is slightly difference in that and the previous one, but this is the more simplified way of evaluating the brittle material and more simple way. So these are the criteria for the brittle material in which we are focused on the ultimate tensile strength rather than the yield strength of the material. So in all the failure criteria, there is a fundamental thing that we are comparing the principal stresses with the properties inside the tensile test, inside the compressive test for any material. So in each criteria, we are comparing the principal stresses with the these experiment properties. So in one case it is yield point, in the other case it is the ultimate tensile strength. So this is all about the failure criteria, and we will move to the other topics, inshallah.